everyone, welcome to our third module for CCNA Routing and Switching Curriculum Scaling Networks version 6.0. Again, this is your virtual instructor, Engineer Ernie E. Pineda. Alright, so this week's module, we're going to talk about EtherChannel and HSRP. Alright, so again, a very interesting topic ahead of us for this week's module. Alright, so without further ado, let's start off with our objectives. Alright, so we're going to talk about EtherChannel, okay, also known as the link aggregation. So we're going to talk about its concept and explain how link aggregation operation in a switch LAN environment. Alright, so we're going to describe it and we're going to take a look at EtherChannel technology. And then later on, of course, after learning the theories behind EtherChannels and link aggregation, okay, we're going to try and configure a link aggregation setup. Alright, using our sample PKAs. Alright, so that is configuring link or EtherChannel links and also how to troubleshoot EtherChannel implementation. Alright, and also with this topic, we're going to talk about the first hop redundancy protocols. That is another subtopic of this module. Alright, so we're going to learn how to implement HSRP, okay, along with the different principles and protocols that is related with this topic. Alright, so including how it operates, the configuration using Cisco iOS commands, along with the troubleshooting. Alright, so let's begin. Okay, so moving on, let's talk about the link aggregation concepts first. Alright, so when we talk about link aggregation, okay, it is actually the ability to create one logical link using multiple physical links between two devices. Okay, so this allows load sharing among the physical links rather than having spanning tree protocol block one or more of the links. So for example, in this given topology, you notice that we have two redundant links connected from our multi-layer switch going to our regular switch in the middle. Okay, but of course, in module 2, we learned that when you have this kind of connection or redundant link that is set up like this, the spanning tree protocol, okay, works by default. So it means it will block redundant links, okay, in order to prevent routing loops. Alright, so we learned that in our past module, okay, that is module 2, okay, but in this module we're gonna talk, or we're gonna configure it differently. Okay, link aggregation is the thing that we are going to combine. So when you look at the second or the next slide, we are actually creating what we call as an interchannel. Okay, that is combining two or more switch ports, okay, in order to maximize or in order to increase its bandwidth capacity. Okay, so for example, let's say in this topology, let's say on this port right here, it has 100 Mbps. Alright, and then the other one has also 100 Mbps. So when you combine those two ports and then you form an ether channel link, you're actually combining their bandwidth capacity as well. So instead of having two separate 100 Mbps, okay, so 100 plus 100 is equal to, alright, that's it. No? You are having 200 Mbps speed by bundling those two ports, okay, making it making it an Etherchannel link or an aggregated link. Okay, so moving on, let's take a look at the implementation restrictions. Okay, whenever you wanted to implement Etherchannels. Okay, so we all learned, or we are all aware, all right, that Etherchannel groups multiple physical ports into one or more logical Etherchannel links. Okay, but before you actually plan on creating Etherchannels, okay, there are some restrictions. Okay, so you need to remember, at least be aware of the following restrictions so as not to complicate your Etherchannel implementation. Okay, so for number one, okay, it says here that when you're creating an Etherchannel, okay, just make sure that the interface types are not mixed. So it means interface types cannot be mixed. So what do you mean by that? So for example, let's say on the following port, okay, some of our switches has a combination of fast Ethernet and gigabit Ethernet, right? So it means if you are creating an Etherchannel link, make sure that you don't mix the fast Ethernet ports with the gigabit Ethernet ports. Okay, so you can combine two or more fast Ethernet. You can also combine two or more gigabit Ethernet. Alright, but not, okay, not the ports that has a different speed. Alright, so that is clear. Okay, next, the second restriction, it provides full duplex bandwidth. Okay, the maximum is up to 800 Mbps for fast Ether channel. So if that is 800 Mbps, means you only have a maximum of 8 ports. Okay, when you are combining fast Ether channels. Okay, also 8 Gbps for gigabit Ether channels. Okay, now in total, a single Cisco iOS switch can support up to 6 Ether channels. Okay, so please do remember, and if you can, just take note of the values that are mentioned here. Okay, so they might pop up on one of your worksheets and activity scenarios. Okay, offline and online activity scenarios, including our quizzes. So I highly suggest that you take note of those keywords, or at least those default values. Okay, next restriction. Ether channels are created between two switches or a server and a switch, like what we have in our sample topology on our previous slides. Okay, next. Okay, now this one is very important. Okay, to create Ether channel, if one side is configured as trunk, the other side must be trunking as well. Alright, take note of that. Okay, so you have a trunk on the other end. The other end should also be trunking. So we are implementing Ether channel on trunk interfaces. Take note. And then at the same time, they should have the same native VLAN. Okay. Next, the last but not the least, each Ether channel has a logical port channel interface. So you will assign, okay, during the configuration, they will be assigned a unique logical port channel numbers or IDs, okay, wherein any changes to this channel interface affects the entire physical interfaces. Okay. Okay, moving on. Alright, so ether channels can be formed through negotiation using one of two protocols. Okay, so you need to remember this one. So first we're going to talk about the first out of two protocols, okay, where ether channel can be formed through negotiation. Okay, the first one is called the PAG, or the two protocols are PAGP and LACP. Alright, PAGP right here and LACP protocol. Okay, so let's start off with the first protocol. Okay, the PAGP, pronounced as PAGP. Okay, so PAGP is a Cisco proprietary protocol that aids in the automation creation of ether channel links. When an ether channel link is configured using PAGP packets are sent between ether channel capable ports to negotiate the forming of a channel. So it means it is an auto negotiation. Okay, it depends on what mode are you going to set up on each end of the switch. Okay, now when PAGP identifies match Ethernet links, it groups the links into an ether channel. Then the ether channel is added to the spanning tree as a single port so that STP will not block it. Okay, once PAGP is enabled on both switches, it already manages the ether channel. Okay, so PAGP packets are sent every 30 seconds. And it also checks for configuration consistency. Alright, and then at the same time, it manages the link additions and failures between two switches. It also ensures that when an ether channel is created, all ports have the same type of configuration. Okay, now, in order for you to run PAGP, okay, notice the table on this slide. Okay, so this figure shows the modes for PAGP. Okay, so we have on, okay, we have the PAGP desirable, and then we have the PAGP auto. So we have three modes right there. So we have on, desirable, and auto. Okay, so let's take a look at on first. What does on means? Okay, so when a certain port is configured as on, okay, it means that this mode forces the interface to channel without PAGP. Okay, interfaces configured in the on mode do not exchange PAGP packets. So it means it is a manual on. Okay, remember that. Okay, so you're just opening the link without any protocol involved. Alright. Now, the second mode is called the PAGP desirable. Okay, now this PAGP mode places the interface in an active negotiating state in which the interface initiates negotiations with other interfaces by sending PAGP packets. So this is where PAGP actually works. Alright, whenever you set it in a desirable mode. Okay, this is when PAGP packets are being sent. Now the last one, the PAGP auto, places an interface in a passive. Okay, so take note of the difference. Okay, PAGP desirable makes the port active. It makes the port active in terms of port negotiation. All right, PAGP auto, on the other hand, places the port into a passive negotiating state. All right, in which the interface responds to the PAGP packets that it receives, but does not initiate PAGP negotiation. Now, also, please take note of the possible combinations, okay, of the different modes for you to be able to establish ether channel link. So you notice, no? When S1 and S2 both modes are on, automatic, yes, channel establishment, yeah. Okay, if S1 is using either auto or desirable, and S2 is fixed into using desirable. Alright, that means it will establish a channel connection. Okay, so it means either of these two, whether this one is auto, the other one is desirable, as long as it has a combination of auto, desirable, 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 alright, it will still establish a channel. Next, if S1 has either on, auto, or desirable, but on the other side you did not configure any mode, there's no channel establishment. Take note of that. Okay, S1 is on, S2 is desirable. Look at that. This one is manual, the other one is active. It still will not establish channel. Okay, the next one is auto or on. While paired with an auto, it will not establish a channel. So it means this one is in manual. For example, you put it on, the other one you put it in auto, means you're setting it in a passive state, listening state lang siya. All right, so there's no initiation right there. There's no one that will initiate the PAGP connection. So therefore, no channel establishment will be no channel establishment will occur. All right, so please take note of the combination. This will be useful. All right, when we are already on our packet tracer activities, particularly in troubleshooting EtherChannels. So you will be given sample scenarios like this, and then you will need to check if proper modes have been configured. If not, then you will be the one to correct it. Okay, using a working combination of modes to establish channel. Okay, next up we have the LACP, or also known as the Link Aggregation Control Protocol. Okay, so if PAGP is Cisco proprietary, LACP is part of an IEEE specification under 802.3AD that allows several physical ports to be bundled to form a single logical channel. Alright, LACP allows a switch to negotiate an automatic bundle by sending, this time LACP packets to the peer. It performs a function similar to the PAGP with Cisco Interchannel. That is because LACP is more like an international standard. Okay, it can be used to facilitate Etherchannels in multi-vendor environments. So that's what the standard means, right? So for example, if you have switches that are not running on Cisco or other brands other than Cisco, then LACP will certainly work with that. But also, in terms of Cisco devices, both PAGP and LACP protocols are supported. So there won't be any problem whether you're using a Cisco or non-Cisco switch in order to form a LACP channel. Okay, now LACP provides the same negotiation benefits as PAGP. Okay, so LACP helps create the interchannel link by detecting the configuration of each side. So all mostly the same with PAGP, and making sure that they are compatible so that the interchannel link can be enabled when needed. Okay, so let's take a look at the figure and then compare it with our PAGP a while ago. So also in LACP we have these modes, no? So we have the on mode. Again, the on mode forces the interface to channel without LACP. Alright, it interface configured in the on mode to not exchange LACP packets. So it's just a manual on without negotiation. No protocol running. Okay, the other mode is the LACP active. Okay, so the LACP mode active places a port in an active negotiating state. So from the word active. In this state, the port initiates negotiations with other ports by sending LACP packets. So it's almost particularly the same with PAGPs. What type of mode? Desirable. Correct. So PAGP is desirable. Its equivalent mode in LACP is active. That simple. Next, the last one is the LACP passive. Alright, so the LACP passive mode plays a part in a passive negotiating state. So again, it's the same in this state. The port responds to the LACP packets that it receives but does not initiate LACP packet negotiation. Remember that. So you have the passive, then you have the active. Okay, the active is more like the auto of the PAGP. Alright, so you see the connection now. Okay, so you have the on, remember, you have the active, you have the passive. Now moving on with the combination. Okay, again, no? Manual on and on. Yes, establish link. You use either active or passive on the other side and combine it with an active. On the other side, link will negotiate a link. So that means active, active, yes. Passive, active, yes. Active, passive, yes. Okay. On active or passive on the other side, but the LACP mode is not configured on the other side, no channel establishment. So you just have to make sure that both links are configured with the correct type of mode. Okay, moving on to the other combination. For example, in S1 you have manual on, while in S2 you configure the mode to act as active. Again, there's no channel establishment. Why? Probably because S1 is in manual. It means it doesn't run any protocol. So even if you put S2 in active mode, it means it will initiate negotiation. Okay? There will be no one to respond to its LACP packets since the other side is configured with no protocol running. Remember, on means that the channel member without negotiation or no protocol will occur. Alright, and then the other one, okay, when you combine the passive on to both passive, okay, definitely there will be no establishment. So manual into passive mode, okay, passive will just wait for the LACP initiation but doesn't initiate it itself. So either way, if you configure it at an active mode, still if the other side is in the on mode, it's manual mode. So it means there will be no negotiation on that channel link. All right. Okay. So hopefully you understood, or at least the modes for each link discussed here are very clear, because again, as I've said a while ago, you will be using the learnings from this couple of slides, previous slides, particularly in terms of the PKA troubleshooting when you have the LACP and PAGP PKA exercises. Okay? Okay, class. So before we proceed with our next topic or next objective, okay, let's try and have a understanding check for both PAGP and LACP negotiation topic. Okay, so in this exercise, we're going to try and match the PAGP and LACP negotiation terms to the description. So these are the different modes that was discussed from the previous slides. Okay, so we're going to try and drag the appropriate PAGP and LACP interface negotiation terms to the appropriate descriptions in the table. So let's go ahead and try to answer this one. Okay, now the first one, it says here, okay, what mode places an interface in a passive responding state but does not initiate PAGP negotiation? So you have your choices here. So it is a PAGP protocol. So which mode places an interface in a passive responding state under PAGP? Alright, protocol. What do you think? You have? Alright, so let's see. That is author. Okay, next. The second one, we have initiate LACP negotiations with other interfaces. This one is LACP, initiate. Alright, you're correct. It is active. Next, actively initiates PAGP negotiations with other interfaces. This one actively initiates PAGP. So it is a mode under PAGP. Alright, so if you thought desirable, that is correct. Or let's see later if your answers are correct. Next, it forces Etherchannel state without PAGP or LACP initiate negotiations. So if this mode is selected, there will be no protocols to run. Okay, so it will just manually force Interchannel state. Alright, so that is on. The last one, it places an interface in a passive responding state under LACP protocol. Alright, so you have no choice. That is the last answer right there, so we just might as well drag it on that question. Alright, so let's see if our answers are correct. Alright, so yeah. So if you followed the slide, the previous slides, and then if these are your answers, then I think it's all good. Okay? Okay, moving on. Okay, good job a while ago for answering the terminologies, okay, or the mode related to PAGP and LACP. Okay, this time, okay, we're gonna try and answer whether if a certain combination of modes will result into a channel establishment. So we just have to say yes or no on the following questions. All right, so let's see. So this one is a PAGP mode. Okay, so switch one mode, the other side has desirable, the other one has desirable. So what do you think? Will it establish interchannel? Okay, let's see. Yes. Next, combination of auto and auto. Okay, if you answered no, let's see later if it's correct. Next, the other side S1 is manual on, switch 2 not configured. Okay. Next, auto, desirable. Okay, so desirable means it will initiate PAGP packets. Auto will respond to any PAGP packet initialization. So you have yes, on, desirable, on, desirable. What do you think? On has no protocol. Desirable will negotiate PAGP packets. So that is no. So yeah, okay, let's see if your answers are all correct. Yeah, right there. So again, no, you just have to if you missed one or two, then I suggest you probably need to review the combination of PAGP modes ready to negotiate from previous slide. Okay, so I think let's see if we have another practice quiz on the next slide. Alright, so we have here, this one is the last exercise. So this time we're gonna try and look at the LACP mode combinations. Okay, so let's see if we can get this one right. 5/5. So the first one you have passive, then the other one is on. Passive and on. No. Okay, on and active. On, no protocol. Active, it will send LACP packets. So still no. On and on. Manual, both. Yes. Passive and active. Okay. Passive and passive. Passive and passive. Of course. Okay. So let's check. Alright. So I hope you get all of those answers correct. Okay, by this time, no? You should have already an in-depth or clear understanding on what particular modes to use, okay, in order for LACP or either PAGP establish an Etherchannel link. Okay, good job, guys. Let's move on to our next topic. Alright, so moving on with our configuration. So this is the most awaited part of this module. Okay, so after we learn the theories on how both protocols can establish a Etherchannel, or when and where, when does uh, this protocol establish an Etherchannel link by combining the correct mode, okay, for link establishment. So this time we're gonna go ahead and look at the configuration on how to run the Interchannel. Let's start off with the LACP standard, okay, or the LACP protocol. Alright, so first step, okay, so we need to specify the interfaces that compose the interchannel group using the interface range. Okay, so it's better if we use the range command. If you remember, we learned this in CCNA 2. Okay, so it is used to select multiple uh, switch ports or multiple physical ports, okay, particularly on a switch. Okay, so for example, let's say if we use a command, let's say if we are trying to create an interchannel for port 1 and 2, so we just simply say interface range and then mention fast Ethernet 1 to 2. So if you're combining 2 or more, probably, so you have 3, 4 ports that you wanted to be part of the Etherchannel, then you just have to change 1-4. Okay, it's that simple. So press enter. Then after that, you're gonna enter the config if range mode. Okay, inside that mode, okay, this is the second step. Okay, so we're gonna create the port channel interface within the channel group identifier, and then we change the mode according to what we want it to run. Okay, so since we are using LACP here, so we're just going to use on. It's either on, active, or passive, okay, to run LACP. So to do that, okay, the command is channel dash group, okay, space. The one right here is the channel ID identifiers for like a VLAN 1, for example, if you're creating VLAN IDs. And then mode space, what kind of mode you would like to run for that particular channel. Okay, so it means this interfaces, fast Ethernet 1 to 2, will become part of channel group number 1 with an active mode on this side right here, on particularly on this one. All right, next, step 3. Okay, the next procedure is making that port channel, switching it into a trunk mode. So you are changing the entire port channel mode into trunk. Okay, they are already not an individual or not as individual physical interface. So to do that, so under the interface or config if range mode, you type in interface. This time we're gonna do port dash channel space 1. Alright, so if you remember, no, interface VLAN 1, it's just the same. This time, it's just going to be port dash channel 1. So you are entering the port channel, okay, because we wanted to change the property or the mode of that particular channel. And then when you're inside that channel, okay, that is the time you switch it. Okay, so switch port mode trunk. So as we mentioned a while ago, one restriction to run interchannels that the ports must be configured or the channel must be configured as trunk. Okay, so this is how you do that. Okay, this is the command that will enable chunk on that particular channel. Then after that, so the other one is just this one is an optional command, but if you don't do this one, it will just by default allow all VLANs to pass. But just in case, okay, on your activity, or if you wanted to run a particular VLAN or that particular channel, okay, then the command will be switch port trunk allowed. Okay, let's say you're allowing only VLAN 1, 2, and 20 to go through. So yeah, so this is actually the entire procedure to do that. Okay, then of course, after you're done with S1, don't forget that you need to configure also with S2 with the identical command. Okay, let's assume that they are both using port 1 and 2. And of course, the mode on the other side that you will choose should perfectly match the mode that you assign on S1. So if you choose active on S1, probably on S2, we're just gonna place the mode, the channel group 1 mode into, yeah, passive, right? So it's either passive, okay, or also an active uh, mode, okay? All right, so let's have a practice code. Okay, for configuring interchannel, so we have the following requirements. Okay, so first up, we are already inside S1 global mode. So what we need to do is to enter interface range mode for fast Ethernet 1 and fast Ethernet 2. So to do that, the command will be interface range fast Ethernet, all right, 0/1-2. Okay, in here, oh, it doesn't accept any shortcut in this particular uh, sample code, but in packet tracer, if you're using packet tracer, um, you can use the shortcut. Okay, so it's easier that way. Okay, let me just check why is it accepting my command. All right, yeah, you just needed space on this particular format right here. But then again, this is just for an exercise. But of course, in Packet Tracer, you can just use the shortcut commands, and even if it is not uppercase, it will accept it. So in this particular exercise, it just wanted to show the full command, okay, so that we can uh, check it, or at least you can be familiar with it. All right, so to enter the interface, both port 1 and port 2, the command is interface range fast Ethernet 0/1-2. As you can see, we are already inside uh, the config if range. All right, next. Okay, so second step will be creating the port channel interface with the channel group command. Okay, so we're just gonna put in channel dash group space. All right, so just put question mark here to show the available channel number that we can use. Okay, so as you can see right here, as a default for this particular switch, it will allow us up to maximum of 6 channels. Okay, so we're gonna select channel 1 for this particular exercise. So we're gonna type in again channel group. All right, space. All right, we have 1. Okay, and then let's put question mark here again just to see if there are still available commands needed. Okay, then yeah, as we all know, we have the mode. So let's just type that again, channel group 1 space mode, and then question mark. Let's see, okay, what are the available modes for this particular command line. So yeah, these are the different modes right there. So the one that we talked about on the previous slides. Okay, a combination of the PAGP and the LACP protocols. So you have the active, auto, desirable, on, and passive. So we want this channel group to use an active mode. So again, so we're gonna go to channel dash group 1. That's still group 1. ID is 1 mode, and then we're gonna change it to active. Okay, so enter. As you can see right there, automatically it will show you information. It will automatically turn on the link for that particular channel for both interfaces, port 01 up to 2. The next thing we need to do is we're going to configure the switch port setting for that particular channel and then put it into trunk. Okay, or change the mode of that particular channel into trunk. So since we are already inside, okay, so that range, so we're just going to change interface. So again, like our guide, so we're going to do interface port channel 1. We're going to enter that interface. All right, and then inside that interface, we're going to change the mode into trunk. So switch port mode trunk right there. And then it also says in this exercise that we're just going to allow VLANs 1, 2, and 20 to cross the trunk link. So again, if you did not issue any trunk allowed command, by default it will allow all VLANs to cross. But this time, since we have this parameter, so we might as well follow that. So switch port trunk allowed, and then you just have to identify the VLAN numbers that will allow to cross that particular trunk. Alright, so that is the command right there. So I'm just going to enter this one. Then, yeah, right. So we have successfully configured Etherchannel for the first side, which is S1. So again, it doesn't end by just configuring the first side. For example, let's say in S1 configured successfully, so it doesn't end there. So you should be aware that the same configuration at least must also be carried over on the other side, the paired trunk link, in order for the Etherchannel to run properly. Okay, of course, with the exact matching appropriate mode. Alright, so yeah, moving on. Okay, so after you've successfully configured Etherchannel commands, okay, of course, when you try and check, and then you know that the configurations are okay, so you've entered the proper codes, but there are times that when you try and ping, and then when you try to test your network, suddenly it doesn't work. Alright, so succeeding Cisco iOS commands are used to verify the Etherchannel configurations. Okay, so to check if the first command will be the show interfaces and then the port channel ID that you wanted to check. So you will issue it inside privilege mode. So you just have to enter show interfaces space port dash channels, for example 1, then you press enter. It will show you information about that particular port channel to verify the interface status. Okay, so the next command, so as you can see, this one has all line up, protocol port channels up, line is up, that is an up status, so the connection is good. Okay, the other command shows you the Etherchannel summary. So inside privilege mode, you just have to enter show Etherchannel summary. Okay, so this command will display one line of information per port channel. Okay, so for example, in this case, it will show you which group or what groups are indicated in that particular switch. Okay, what channels are created. So in this case, we only have one channel group in use. All right, right there. And of course, the most important thing, it shows you what protocol is being run on that particular Etherchannel. All right. So this one uses LACP, and at the same time, it will also show you the bundled ports. Okay. So this one, it shows the one that we configured a while ago, a port FA0/1 and FA0/2. Okay, so that is show Etherchannel summary. So take note of those show commands. Very useful, especially when you are trying to troubleshoot an existing Etherchannel configuration. Next, we have the other command, the show Etherchannel space port dash channel. Okay, so again, we use the show Etherchannel port dash channel command to display information about the specific port channel interface. So as shown in this output example. Okay, so you can see here that port channel 1 interface consists of two physical interfaces. Okay, two physical interfaces. That is port 1 and 2. All right. Also, it uses LACP as its protocol. In active mode, of course, it is properly connected to another switch with compatible configuration. That's why it's running a certain LACP protocol. Okay, so yeah, that's it. All right, and then the last one is the show interfaces, and then for example port 01 space Etherchannel. So this command can provide information about the role of the interface in the Etherchannel. So in this case, we are trying to check the role of port 1 in the Etherchannel ID. Okay, so yeah, so you just have to remember all those show commands. So particularly the show Etherchannel summary. Okay, this one is the one that's being mostly used actually when it comes to checking the Etherchannel status configured on a particular switch. Okay. Okay, next up, after verification and checking the Etherchannel summary using the different show commands, it's now time to interpret some of the outputs, particularly for those Etherchannels that are not functioning well or that are not functioning properly. So this one is an example of a troubled Etherchannel. So for example, let's say when you issue show Etherchannel summary, and then you notice under flags, okay, be aware of those particular flags. When a certain indicator like this one, you can see letter D on port 1 and port 2. Alright, they're flagged as D. D means down. Right? So it means there's something wrong with that particular port. Okay, so it's either you have to check, it's either if the modes are correct. Okay, if both ends are using the correct mode in order for a certain protocol to negotiate or to establish properly. Okay, you need to check on that. Right? So those are the things that you need to be aware of. Okay, of course, aside from other physical checking, like let's say like the restrictions that we mentioned during the start of this module, you need to assign all ports on the same VLAN number. Okay, configure them as trunk. Okay, also ports must have the same native VLAN. Alright, ports with different native VLANs cannot form an Etherchannel, so we learned already about that. So you have to take note of that as well. Configuration of trunks on Etherchannel is very important, so you need to verify if the trunking mode on the Etherchannel is working. Okay. Also, an Etherchannel supports the same allowed range of VLAN on all ports. No? So just in case, for example, you notice that all configurations are good, but a certain VLAN IDs cannot communicate with the other VLAN group. Okay, so you might as well check if that VLAN ID is allowed or disallowed to pass through a particular trunk, especially if uh, uh, there's a configuration that allows or disallow a certain VLAN to pass through. Okay, and also you need also to make sure that the dynamic negotiation options for PAGP and DAC must be compatibly configured on both ends. Now take note, on both ends of the Etherchannel. So these are the series of troubleshooting interfaces or troubleshooting techniques that you need to check. Okay, particularly when you're working on a certain, let's say a packet tracer that is being designed for uh, troubleshooting Etherchannel. Okay, so yeah, I guess that's it for this module. I figured for the HSRP, we might as well. This video has been gone too long for uh, Etherchannel alone, so I figured, okay, for the HSRP, we're just gonna have to discuss that on our live classroom setup. Okay, that is still part of this module, but just wait for my announcement inside the CAD. On when are we gonna have the live session, online session for the HSRP, okay, or the other subtopic for this particular module. Okay, so with that, I guess we're good with this module. Okay, the PKA exercises has been uploaded and they are already scheduled accordingly. So just follow the submission deadlines along with the worksheets that you need to submit. And then I'm just going to entertain if you have questions about Etherchannels. We're just going to have to talk about that during our live sessions, particularly when we added the HSRP topic. Okay, so I guess that's all for Module 3. See you guys again on the next module. Alright, goodbye, and thank you for listening.